Yeah, okay. Right, so today is the 31st and our 5th session. Today we're going to be talking about scope. I know we have mentioned scope before and described it as the area in which you can access variables. I just wanted to touch on it in a little more detail. So in JavaScript, scope refers to where variables and functions are accessible in your code. So there's two types of scope. There's the global scope, which means it can be accessed anywhere. So any variable declared outside of a function and not within a block or a curly brace is going to be in your global scope, and you can access them anywhere inside the program. Local scope is defined within a function or within a specific section, and is only accessible within that function or section and any functions or blocks of code inside of it. So that means if I have a function in a function, if I have a variable in the first function, it'll be accessible within it. Similarly, any kind of local scope will override global scope, and there can be multiple levels to this depending on how many levels you nest blocks or functions. So here's an example. So here we have a variable Tom, which is declared at the very first thing. It's not in a function, so it's available everywhere. So I can print it right here. Then I can make a function that says say hello, and it will return the name. And then when I run say hello, it will return Tom. So even though this variable was not declared within the function, it is still accessible because the name has a global scope. Here we have local scope. Here I made a variable age within the function, and it can be accessed within that function. If I were to try to console log this age outside of the function, it would not work. I can give a brief example. Let's open up a console real quick. Here I can make a function, say hello. And here I can say, let my greeting equal hello. And here I want to return that greeting. So I can call the function because the function itself was declared not within a function, so it's in the global scope. And if I do it, you'll see hello. But if I try to access this variable greeting, what is greeting? It's going to say that it's not defined. Now, because the function was declared at a global scope, that means I can access it within another function. So here I can make a function, what should I call it? Second function. And here I want it to, use say hello. So here I'm going to say it returns say hello. And it will be able to access this function because the function was made at a global scope. So now I can run second function, and it gives me hello just as well. But neither this function nor at the first level will I be able to access the greeting variable. Now, you can place functions within functions, and we have done so before. We've mostly done it with the fat arrow notation because it's a lot cleaner. But let's say I make a function. I'm going to say first, and within it, I'm going to have, let's make a variable. Actually, this would be easier to do in a file. So let's go here, and I'm going to say function first, and inside it, I want to make another function called second. Now in the first function, I'm going to make a variable x, and it equals 10. Now within the second function, let's say I want to return x, a function that was returning a variable that was not declared in its function, but in another function higher from it. So the rule for local scope is that a variable declared within the function is available everywhere within the function. That will naturally include other functions inside of it. But if I were to make a variable inside of here, it will only be available here and not within the entire first function. So now let's make this return second, and this should give me 10 if I give it a run. Oh, I have to call it naturally. Yeah, and that gives me 10. So I'm able to access x within another function. But if I were to try to access x here, it's going to complain it's not defined. Similarly, if I was to make a variable, let's say y equals 20 here, and here I wanted to return y, it would not work because y has not been defined within the first function. I give this a run, it's going to complain y is not defined. All right. Are there any questions about global versus local scope? No? All right. So now we're going to get into hoisting. And I did mention this earlier, and we had some difficulty running it in the past. And this is an interesting property of REPL. Hoisting does not occur in a REPL console, but does occur in JavaScript files. So here, what hoisting means is that when I try to access a variable before it's been declared, JavaScript will automatically move the declaration to the top of the area where its scope would begin. And that means if I were to place x, instead of putting it at the beginning, let's say I were to put it down here. And here I wanted this function to return x. So I didn't declare x before I started making this function. But let's see what that does. Oh, hold on a second. Yeah, it's an interesting property of REPL down here, that x. There we go. That works just fine. So even though I didn't, you would think that I'd have to make x here before I'm able to even return it because it's trying to return something that doesn't exist yet. But it automatically changes it to something like this. It declares it, it sets the value, and then it calls it with the current value. So it won't complain because it hoists the value up, which means to move the declaration. So remember, there's a distinction between declaration and definition. Here I define what x is, the actual value associated with that variable. But here I am declaring there is a variable x. But if I don't do it, let's say I did it down here, it will automatically move it to the beginning of the scope in which that variable should be declared, which is the very top of the function. It's not going to be out here because it's not at a global scope, it's at a local scope. All right, so that's hoisting. Here you see I have name. Instead of saying name is not defined, it just gives me undefined. Because for all intents and purposes, it moved the declaration of name up above that call. And in the second call after I assign a value, then I do get Tom, which is the value I'm trying to assign to that name. So it's a mechanism where variables and function declarations are moved to the top of their scope before code execution. Is there any confusion about hoisting? No? All right. So that's really all there is to scope. There isn't a lot much else to say about it. So if we don't have any questions about scope, we can move into some exercises. All right, let's see here. Bootcamp Prep. And our first problem. We're going to start with a warm-up problem called Rectangle 1. Yes. So you need to write a method that takes in two number arguments representing the length and width of a rectangle, and then need to return the perimeter of a rectangle with those dimensions. Just as a recap, the perimeter is the length traveled around all the sides. So a rectangle has, two sides here, two sides here. So you just add up all of those sides and you have the perimeter of the rectangle. All right, are there any questions about this problem? No? All right, I'm going to send you all the link. You will have 10 minutes to work on it. Where's the chat? That's interesting, I can't, oh, there it is. All right, you should be able to see the link in the chat. You have 10 minutes to work on this problem, and I will see you then. All right, so the formula for the perimeter of a rectangle is 2 times its length plus 2 times its width. And we know this because a rectangle has 4 sides, 2 of which are equal in size. You could say that's the width, 2 of which are equal in size. That would be the length. So you add those up, and that gives you the perimeter, which is the entire length of all of its sides. So we are given the length and the width respectively, although if they were to be swapped, it wouldn't really affect the formula because addition doesn't, the result doesn't change regardless of the order in which you add numbers. So let's go over to our index.js. So they have length and our width. And again, if they said the length was 2 and the width was 3, or the length was 3 and the width was 2, it wouldn't matter. Although canonically the length should be longer than the width, it doesn't necessarily have to be. So let's go in here. And what I would return is you could say length plus width, or you could just say length times 2 plus the width times 2, which is the same thing. And remember here, our order of operations still holds. So multiplications will occur before addition, then they'll be added up together, and that'll give us our final solution. So let's write ourselves one test right here. And the question is, are these going to be equal? And if I give this a run, I should see that they are true. It is. Great. Are there any questions about this problem? Nope. All right. So that's our rectangle 1 warm-up exercise. The next question is presidential info. All right. I should probably erase this. Great. All right. So in order to be elected president, you must meet certain qualifications, such as being at least 35 years old and being a natural born citizen. Write a method that takes in the last name of a person, their age, and their country of birth for a presidential candidate in that order, that returns true if the candidate has the potential to be president, or false if they do not. So again, the only 2 things that we're considering are their age and the country in which they are born. Are there any questions about this problem? Nope. All right. I'm going to send this in the chat. We'll have 15 minutes to work on this particular problem. All right. I'll put the timer on. All right. And I will see you in 15 minutes. All right. So the presidential info problem as to whether or not a person qualifies for president based on whether or not they are at least 35 years old and are a natural born citizen of the US. Now, a little thing that might have been misleading is that we take 3 arguments, namely their name, their age, and their country of birth, but we never actually use the age. And you'll find very frequently that we might receive arguments that aren't being used. And this could be a result of backwards compatibility with existing use cases of this function. So you'll find in a lot of large projects that you might have a function, and then in future updates to that function, you'll change the code. And in that future code, you might realize a certain argument isn't needed anymore. But you still have to maintain that function signature so other tools and other code that uses that project still works. So it's not wrong is name the variable that is not being used in this function. Yes, it is. It's because we have a person who has a name, an age, and a country. So it kind of makes sense that when I'm asking for president, we might ask for all 3. That is how the question was posed to us, regardless of whether or not name was made. All right, so here, we don't have to look at name at all. We can just ignore it. if you were writing this from scratch and you weren't given a prompt or a question to write in a specific format, you might have elected to just provide the age and the country. But since it was told that you must provide name and a country, you can make it take name even if it's not being used. So here, there's two conditions to check for: whether the name is at least 35, the age is at least 35, and the country is United States. So you could you could check both of them, but you have to check that they're both true. If one is true and the other is false, that person does not qualify. So, you could be 60 years old and be born in Canada, and you would not be eligible to be president. Similarly, you could be born in the US and be 12 and you're not eligible. So they must both be true. So you have to use the and operator, not the or operator, on both of these conditions. So you would want to return that the age is greater than 35 and that the country equals United States. Now, right now, it's specified that we define this country using this explicit string. Now, we could have been picky and said, oh, they provided the country in lowercase. Should that be equal? So I could just do it like this and say United States and check the country dot to lowercase equals it. And that could be fine, but I have yet to meet anyone who writes the country in lowercase or mixes cases. You might see USA, you might see United States of America. So you could check for multiple string conditions, but that was not what was asked of in this question. So if you didn't provide that, that is equally valid. If you wanted to check for multiple strings, you might want to keep an array of equally valid strings. So let's say here, I make an array like, I could say USA, I could say United States, and I can ask you, is the country in this collection? Could I say USA is in this? No, it isn't, but I'm pretty sure that should say true if it's in the collection. Oh. Yeah, that's not, in fact, how it works. You could iterate over it and check to see if it's in the array. Of course, you could do it that way. I believe that, I just want to check really quickly. JavaScript array contains. See, again, you're not expected to memorize the, oh, yes. At least 35. Yes. It depends how you interpret the question. When this, I think saying greater than equal to 35 is probably much more apt. So here you said if Jared said if it's less than equal to 35 and the country does not equal the United States, return false. Greater than equal to 35, you can say return true. Yeah, that does work. But an issue with this is that you don't need to branch on this. If you're returning true and returning false, you could just return the condition directly. Okay. So there is something called includes. So here I could have an array like this, and I can say, does it include the string USA? And then that would return true. So I could have a collection of equally valid strings to represent the country, or maybe countries, and then check that it includes it. And you also have to consider how many different ways that a country could be represented, not just the US, but what if someone wanted to represent a different country? What if you're asked a different eligibility for Prime Minister of Canada, for example? All right. So that's an example of how we could have used the includes method if you wanted to check for acronyms of the country as well. So I would say that a very complete solution would take into consideration that the capitalization doesn't matter. You could check for US, USA, United States, United States of America. So there's a lot of ways in which the country could have been represented here. And you could check, does this array include country that was passed? All right. Are there any questions about this problem? Nope. Right. If you just did this, I would consider that to be or even without checking case, I would have said that it's still a correct solution to the problem. So on to the next question, is detention control flow? So I'm going to go over this, we're going to go over this question, we're going to work on it independently, and after we're done that, we're going to go on a 10-minute break. So all of the students in the 5th and 6th grade have detention. Don't ask me why, they just do. You can tell a student is in 6th grade if 6 is the highest number in their student ID. And if the highest number in the student ID is less than 6, then they're younger. And if it's greater than 6, they're older. The same rule applies for 5th grade students. So if the highest number in here was 5, then they would be a 5th grade student. If it was 6, in this case it is, because you have a 1, we have a 3, and we have a 6. And 6 is the highest number here. So this person must be in the 6th grade, and therefore they have detention. And we also have the same rule for 5th grade students. If the highest number is 5, then they're in the 5th grade. Note that I didn't say that this student has to be in the 7th grade, just that they're not in the 6th grade. So write a method that takes in the student's ID as a string of unknown length. It doesn't have to be the same length, it can be any size, and returns a Boolean true if that student has detention and false if they do not. And remember, when you have a function that simply returns true and false, it's not necessarily the case that you need to branch and return false and return true. You can simply return the condition itself. All right, are there any questions about this problem? No? If there aren't any, I will send this in the chat. And you have 15 minutes to work on this, and I will see you then. All right. Great. Oh, that's not what I was trying to do. Go to detention. So all the students in the 5th and 6th grade have detention. So we have to determine the highest number in each of these strings and see if it's equal to 5 or 6. If it's equal to either of those, then we know they're in either the 5th or the 6th grade, and therefore they must be in detention. So I have two solutions to this problem, one that uses a for loop and one that uses built-in methods. I'm going to start with the solution that uses built-in methods. So the first thing we do is we have this string. And actually, let me just copy a string as an example here. And I want to find the largest number in that string. So the first thing I have to do is kind of look here and say, find all the numbers in this. So you could make a for loop and go over all the characters in that string and say, is it a number between 0 and 9? And there's actually a built-in function in JavaScript called isNaN, or not a number. And it will tell you whether or not a string is a number or not a number. So I can say is not a number, and I have 1, 2, 3. That is not a number. And if I had ABC, it would return true because it is not a number. See, this is false because it is a number. This is true because it is not a number. Now, there isn't a built-in called isNumber, but we can use this by just taking the negation of it. The negation of is not a number, not is not a number, is the same as saying it is a number, right? Not is the same as the original. So this can let me determine if something is or is not a number. Great. This means I can filter on this condition. I could have just as easily said, is it a string value between 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 on each individual character? But this method is built in for us and does that for us. So that's a little less work for us to do. So here we have our string. And before I can iterate over it using the filter method, I have to convert it into an array. And I can do that by splitting it. So now I have an array of characters. And I can filter on it with each character C such that the character is not a number, which means it is a number. So not is not a number on C. And now we have all the numbers inside of it, 1, 3, and 6. So now the question is, which is the highest number within it? Okay, there's something inside of JavaScript called the max method, or math.max. And that can be used to find the largest number in a collection. So if I had math.max, I give it 4, 1, the string 8. It doesn't care if there's strings or numbers, as long as it's numeric and can be converted into a string. This is going to give me 8. But notice that I gave it multiple arguments. I didn't give it one array 4, 1, 8. I gave it the arguments 4, 1, and 8 individually. That's how the math.max function works. So if I have an array, I need to convert it into a version that has all of them as individual arguments. We learned of an operator that does this. That's called the spread operator, and that can spread out all the arguments. So we can use that here on our collection that we've collected, all the numbers. And I'm saying I want to find the maximum value within it, within this array. And in order to pass it correctly to this function, I have to spread the contents. This tells me that the largest value is 6. And consequently, I can just check, is it equal to 5 or 6? And then I am done. And I can say if it's 5 or 6, then yes, they have detention, and I can return true. So now let's actually implement that here. So I can select this and say const largest number equals this value here. Now that is a little bit big, so let's split it onto multiple lines so it's a little easier to parse. .split, .filter, yep, that looks good. Now I just need to return whether or not the largest number equals 5 or 6. So I can say 5 or 6 dot includes the largest number. And I'm not mistaken, that is the name of the method. So if I had 1, 2, 3, I can say, does it include 1? And it's going to return true. So the name of the method is includes. So does it include the largest number? So if the number is 5, I'll get, does 5 and 6 include 5? Yes, it does. If the number is 6, it's going to say, does 5 and 6 include 6? Yes, it does. Alternatively, I could have said it equals 5 or it equals 6 using the or operator, which is 2 pipes, which look like this. So alternatively, instead of doing this, I could have said, you know, largest number. Go back here. Largest number equals 5 and largest number equals 6. And I would return that. And that's exactly the same thing. So why don't I just create a couple tests to verify this behavior is in fact correct. I'll take these 2 down here. And we don't have to check if it's true, because if it's true, true equals true, the former would have been true anyway, so I just have that. And if it's false, that means that this is false, the former, and I can take the negation of it, and that will be true. In any case, I can print the values directly. So now I know the expected output is going to be true and false. Give this a run, and what I see is true and true. That's interesting. Let's see, what is the largest number here? So this is where we can do a little bit of debugging. What is console.log of the largest number? I run it. And they're both telling me the largest number is, oh, do you know what I'm doing wrong? This should say ID. Yeah, I'm operating on the ID, not that fixed string. So now if I run this, I see 6 and 7, which is the expected largest number. So 6 is a number either 5 or 6, so that works, but 7 is not within the array 5 or 6. Therefore, they are not in the 5th or 6th grade and therefore don't have detention. All right. Alternatively, I could have done this with a loop, and let's take a look at that kind of solution now. All right. So what I could do is I can make a largest number, and say it's 0. And this is kind of how math.max works, is I'm going to say, is a number bigger than our current value of what we think the largest number is? If that's the case, we can update our largest number. And we keep going along until we've gone through all the numbers and say, yep, this is in fact the biggest number we've found so far. So we update our largest number. And after we've gone through it all, we'll have the biggest number in that ID. So I can say for some character of the ID, and I just need to say, is it a number? So if, character, if not is not a number on the character, which means this character can be interpreted as a number, then I can do the following. Now, if I had a stringified version of a number, can I compare it to another number like 10, for example? No, I can't. Can I compare it to another string like 7 or 5? I can. So a string 6 is greater than a string 5, but a string 6 is also greater than the number 5. That's interesting. So what if I had, is 6 greater than the string 5? That's also true. So it seems that regardless of whether or not it is interpreted as a string or a number, the operator will still run it successfully. This means I don't need to cast it to a number before I make the comparison. All right, so now I can say here, after I've determined that it is in fact a number, now I can say if our C is greater than our previously largest number that we found within the ID, then we can update our largest number to be this character C. Now, right now, C is in fact a string. So when I return it, I do have to make sure that I cast it as a number. So it goes through all of them and it finds the number. Great. So now I go at the end. And actually, no, that's an interesting point. If I say 5 equals 5 without a string comparison, it's going to return true. So instead of casting it to a number, then saying, is it strictly equal to the number 5, I could just use the loose equals comparison, so I don't have to worry about casting at all. So down here, I could return, is the largest number equal to 5? Or is the largest number equal to 6? Alternatively, I could have used this 5, 6 includes, but this I'm pretty sure includes is a strict comparison, unlike the double equals comparator. So let's actually verify that real quick. If I have 5 and 6, and I say, does it include the string 5? It says no, it doesn't. So includes does use a strict comparison under the hood. So that would not have been appropriate here unless I casted the number into a number before passing it to the includes method. Right, so now let's run this to make sure that our expected output of true and false do appear. And they do. All right. So both of these implementations are correct. The former is a little bit smaller, and I think it's a little bit cleaner. Do we have any questions?
For your first solution, could you just talk through the use of the spreader and the filter? I'm still not really good with that yet.
Okay, absolutely. So we actually have to look at this problem inside out. So we're going to start here. When I have an ID, and let me just copy an ID as an example. Like I was using this example here. So I'm going to say ID equals this. If I split it with the empty string, that means convert it into an array of characters. And I do this because I can only filter on arrays. If I try to apply a filter to a string, it just wouldn't work because a filter is a method that belongs to the array data type. So what filter does is it allows me to choose what I keep and what I remove from an array. Now it's actually a non-mutating method. It doesn't change it itself. It returns a version of a brand new array from that array that's modified. So here I can save this in an array. I can call it my ID, and I can say my ID dot filter, and let's say I want to say does it equal 1, for example. So does it equal 1? And that leaves me with the first one and only the first one. Now I could say does it equal 1 or does it equal 3? And that leaves me with 1 and 3 because they're both present. So filter is used and it takes a function. This is a function using the fat arrow notation. This is the argument in the function, and this is the return output of the function. So I could show you another notation that might be a little easier to read. I could say there's a function here. It takes some argument I, and it has the following body. And I want you to return whether or not I equals 1. And that's exactly the same as what I just did here. So filter takes a function, it's called a callback function, and it returns either true or false. And if it returns true, then for some I in our array, it's going to keep that value in the array. And if it returned false, it's going to remove it from the array. Now, in the myID array that I made, that's still there, but this is the array that it returned. The question is whether or not it stays in the array that it's returned. So that's the filter method and how it works. So here I say filter on the condition, and I chose C because C stands for character, and I'm going over a collection of characters. Now this one requires an understanding of the not a number method. And what this does is it returns true if some string can be converted into a number. So let's say I had a string, 7584. If I wanted to convert that into a number, well, I can, because it is numeric. But if I were to put some random letters in there and I ask you what number is that, it's going to say it's not a number, because what I just gave you here, that isn't a number. So that's what NaN stands for, not a number. So this method determines whether or not something is not a number. But I'm not looking for cases for individual characters that are not a number. I'm looking for characters that are numbers. So I can take the negation of the is not a number method. So when is not a number returns true, that means it isn't a number. By taking the negation of that, I get false, which tells me, it isn't a number. And if I had true, it's false. And if I had false, that means that a number was found. I want it to return true because filter keeps it when it's true. So as a result, this will keep all of the numbers inside of that ID. If I got rid of this negation, it will keep all of the letters within the ID instead of the numbers. So that's me telling it what I want to keep in the array. Now the spreading thing, in order to understand why I had to spread it, you have to understand how math.max works. So actually I can show you the documentation real quick for JavaScript. Yeah, here we go. The Mozilla documentation is great. So here you can see that I pass it a bunch of arguments, and it can actually take any number of arguments. The functions we've made so far, it accepts 1 argument, 2 arguments, 3 arguments, but it's set. This function can actually take any number of arguments. So you can see the first one here, I pass it. The first argument's 1, the second is 3, and the third is 2. And then it gets the max. See here, but if I give it an array, that array is just 1 argument. And it's going to say, well, the array itself is not a number, so it returns not a number. Because it needs to look at each individual argument as a number. So what spreading does is it takes the contents of the array and it basically copies and pastes it out as if it wasn't in an array. So if I made this array, 1, 2, 3, and I wanted to spread it, that's the same as me copying these numbers 1, 2, 3 and ignoring the braces on the end, as if I just put it directly in the function, and those are the 3 arguments. So spreading allows me to take an array and make them as individual arguments. I made a session example on spreading not that long ago. Yeah, you can spread arrays and you can spread objects. And spreading objects has the exact same idea in that it takes the contents of the object and it just copies and pastes it outside. So here I have a function that expects 2 arguments, arg1 and arg2, and I have an array of arguments, hello world. If I passed this directly to the function, it would take this as just argument 1, but I want the first to be arg1 and the second to be arg2. And to do that, I spread the array. And that's the same as me copying this and putting it right inside of there. Right? Did that clear up what spreading is at all?
Yeah, that helped a lot. And it kind of begs another question as to how that line is evaluated. So I understand the filter function is resolved once the split is done on the ID. Then why is the spreader? Actually, I think I just answered my own question.
Yeah,
I'm good.
This whole thing returns an array. Yeah, because the ID is a string, the ID.split is an array, and when I filter it, it returns a new array that only contains the values that I want to keep. In this case, it's numbers. Then I spread them to the math.max function and it chooses the largest number among them.
Got it. Thanks.
Yep. All right. Do we have any other questions? No. If we don't, I'm just going to delete this and move on to the next problem. Oh, actually, no, now is a great time to take a 10-minute break, and then we can move on to the next problem. So I'm just going to set a timer for 10 minutes. And I will see you in 10 minutes to work on the next problem. All right. So there are a couple of variable naming conventions in programming, and the most common ones you will see are camel case and snake case. Camel case is when the first word is lowercase and all subsequent words in that variable's name are capitalized. Snake case is when each word is separated with an underscore. What we've seen in JavaScript so far is all of our variables have been in camel case. So the JavaScript language subscribes to camel case. Other languages like Python, for example, which you will probably see very soon if in the upcoming cohort, is snake case. So you do have to be familiar with both of them. Camel case is a naming convention for variables that contain multiple words. So if it just contained one word, the whole thing would be lowercase. Like if I said cats, that would be lowercase. But I could say, cats in Canada, and the I would be capitalized, and the C in Canada would be capitalized. So when you have multiple words, they capitalize each subsequent word. So the rules are thusly: the entire first word in the variable's name is in lowercase. Every subsequent word's first letter is capitalized, and there can't be any spaces or underlines between the words or within the words. So they have to be combined together. So here's an example. Here I have a variable called first name. The word first is in all lowercase, and name is capitalized with an N. So there can't be any capital letters mixed inside of the individual word. If I said first and this was a capital S, that wouldn't be in camel case, because that would imply that ST is its own word because it was capitalized. So it'd be fur, ST name, and that well, st isn't unless it's first saint name, but no, it's not what it's saying. So you have to be careful that the contents of the word are in lowercase. So the first letter is in uppercase and all ones after it have to be lowercase as well. So this would be snake case, first underscore name. Right. So in this challenge, you're going to write a function that takes a name in snake case and converts it into camel case. So here you have a function, make camel case, and here it takes something that's in proper snake case. My name is Kramer, and it's going to convert it into my name is Kramer, where the first one is in lowercase and each name is capitalized. Now it is fair to assume that all of these are in properly formatted snake case. So they're not going to have double underscores right next to each other. It's not going to start or end with underscores. You're not going to see random uppercase letters inside of it. So they'll all be in lowercase. Are there any other questions about this problem and the assumptions that we can make? Nope. All right. If that's the case, I'm going to send this in the chat and we will have 15 minutes to work on this problem. Again, please remember the split method that can help you break it into words, and that's going to be very helpful here. So I'm just going to open up the chat. All right. Put 15 minutes on the clock. Great, and I'll see you then. Resume recording. All right, forgot to record. Let's just review this one more time, very briefly. The first solution we had was not using a for loop, but using the built-in JavaScript methods. First thing we had to do is split the words, split the input into all the words, and each word is separated with an underscore. So I can take a string like my name is Kramer and split it with an underscore to get each of the individual words. Then the next thing I have to do is only take the first word as it is in lowercase, and then on all of the other ones after it, I need to capitalize them. Name is and Kramer all need to be capitalized. So I take the first word exactly as it is, and then the capitalization of the rest. So slice can be used to select everything after and including the first index, which is the second word in the array, and I apply the following to each word within it. For each word, take the first letter, make it uppercase, then add the remainder of that word. That leaves me with an array that I can then join into a string with nothing separating it. A delimiter is a word that separates, a string that separates the individual things. So we're going to have nothing in between it. And then I concatenate that to the first word. The second solution was to build our result one word at a time into an empty string. So I still split the words the same way I did before, but I have a for loop that goes over every word. And I actually do it for all of them, not just the, not excluding the first solution. And I uppercase the first letter and add the rest of the word. But then I go back when I'm about to return and make the first word in the first letter of the entire result in lowercase, which is the first letter of the first word, consequently. And the rest of it is as it was, exactly as it was. So both of these solutions work. And we don't have any questions on this. Great. So I think now is a good time for a 10-minute break before we continue. So I'm going to put 10 minutes on the clock, and I will see you then to discuss the next problem. All right. All righty. I should probably delete these before I close it. All right, so the range problem. You have to write a method that takes in a minimum and a maximum integer and returns an array of all the integers between those two numbers in ascending order. So given 3 and 7, it's going to give us 4, 5, and 6. Negative 4 and 1, it's going to give you negative 3, negative 2, negative 1, and 0. You can consider using array methods like pop, push, shift, and unshift. Pop and push will put it to the end of the array. Shift and unshift will put and remove from the beginning of the array. And there are many other methods and a number of ways that you can implement a solution to this problem. Are there any questions as to what this problem is asking us? Any clarifications or assumptions you want verified? No? If there's no problems, I'll put this in the chat and we'll give us a good 15 minutes to work on this one. All right. So there are two main solutions to this problem, one with a for loop and one using built-in methods. I'm going to start first with the built-in method. So the first thing I notice is if I take 7 minus 3, that's 4 values. If I take 1 minus negative 4, that's 5 values. That's one more than the number of values in the array I wish to generate. The second thing that I notice is that it starts at 1 plus the lowest value and ends at 1 minus the highest value. So with these properties, I can do something pretty interesting. The first thing is I can create an empty array that has a length that is exactly this size. So let's say I have an array constructor, and let's start, say, the lower bound of the is 3 and the upper bound is 7. So you can see that A is the first argument, B is the second. One thing I know is that the length is going to be B minus A minus 1. So that's 3 elements in this case, for 3 and 7 respectively. So you can create an array of size B minus A minus 1. And it has 3 empty items. It has a space there, there's an index there. And if I try to index that array at 0, I get undefined. 1 is undefined, 2 is undefined, 3 doesn't exist, but it's also undefined. So it has 3 empty items there. And I can get the keys at those locations. And this creates something called an iterator, which means I'm able to request the next value from it. So if I can make a for loop over this, for I of this, I can say console.log I, for example. Oh, hold on a second. My bad, sorry. You would have to spread a generator to actually get the contents of them. 0, 1, 2. Again, I don't expect you to be familiar with array construction. This is just one of many solutions, and I will go over the alternative using for loops after this. So here I'm able to build an array 0, 1, 2 and get the keys of those. In this case, the key of an array is just the index, right? So it's not a key value pair, it's an index value, if I will. And each one of them being undefined, I don't care about the value there. More, I just care to generate a sequence of values that is incrementing. And one thing I notice is that since it starts at 4, all I have to do is add to each one the value 3 plus 1, or in this case, negative 4 plus 1. So it's always going to be the lower bound plus 1. And if I want to do something to each value in an array, I can use a map. So I can say I have some index I, and I want to return that index I plus A plus 1. And that gets me 4, 5, and 6, the exact desired outcome. So now let's go here. And actually, I do want to go over here and copy those example outputs so I can make some tests. I'm going to console log this to the screen so I can see my tests. and verify that it is giving me the correct output. So here I'm able to simply return the array that consists of the values 0, 1, 2, or 0 through the value of, so it's going to be however long the array needs to be, from 0 up until the length -1. And we're going to increment the first value with the lower bound +1 because it's inclusive. Exclusive, sorry. It's not going to include this value 3. It's going to have the value right after it 4. So that's why I add 1. Now, of course, this value isn't B, it's called max. And this value isn't A, it's the min, which is a much more apt name to describe this. And it's going to return this. Ooh, that's interesting. Let's see what results we're actually getting and why it returned false. Four, 5, and 6, -3 through 0. Oh, that's right. Remember, we can't do array comparisons by just using the comparator operator. Comparing arrays requires us to make a function for comparing arrays by value instead of by reference, which means that they're referring to the same underlying array. So we can just look at it and verify that this is in fact our expected output. So now let's look at, before I move on to the for loop, how about I take any questions pertaining to this particular solution? Do we have any questions? Again, to clarify here, I create an array of a specified size. I know that it's going to be max minus min minus 1 length. So if the max was 7 and the min was 3, and I subtract 1, that will give me 7 minus 3 minus 1 is 3. And that's exactly how long it should be. And I'm saying build an array with 3 things in it, and I get the keys at those locations. So that's the indices 0, 1, 2. So this builds me an array 0, 1, 2, but it builds it in something called a generator. And in order to build an array from a generator, you need to spread it. That is how generators work. And a generator is a value where it doesn't create the whole array at once. It creates it describes how the array would be created. So I can say, get me the next value, and then it makes it. So imagine if I had a range of 1 to 1 billion, it would make the generator instantly. But if I asked to spread that array, it would take time because it actually has to make all of them and put it in memory. But the generator is useful in that regard, in that it's much faster and it only gives you the results immediately when you need it. So here I'm saying, give me all the values at once. I need to spread all of them as arguments and then put it in an array. So that's why an array constructor will actually build it using the generator. So now I have my array 0, 1, 2, and I need to map each of those indices 0, 1, and 2 to take the value that's presently there, 0, 1, and 2 respectively, and increment it by the lower bound 3. So the first one is, now it's going to be 3, 4, 5, but I need to add 1 to it as well. So that becomes 4, 5, 6. And the same logic applies to any different minimum maximum bounds, resulting in our other answers. All right, so if we have no questions on this particular solution, we can move on to the for loop solution. So one thing we do know is we can have an empty array and we can add new values to the end of it, or using push. So let's say I want to have let my result be an empty array. I can have a for loop that iterates. So I'm going to say for let I equals min plus 1. So I'm starting at the minimum value plus 1 because I don't want to include 3. I want to start at 4. I'm going to say while I is less than max, but not equal to max, I plus plus, which means I increments by 1. Great. So now I can say res dot push, which means I'm adding a new thing to the end of it. I would just want to put I in it. And then I can return that result. And these give me the exact same results. Are there any questions for the for loop solution?
I have a question. So it seems like the main difference between your two solutions is that the first one is more efficient with memory as the size of the range gets larger.
Yes, that's right. The first one, I have to store the entire array in memory and add a new thing to it. The second one only has to, it generates it and then builds it as necessary, and then it maps the values onto it. So this never stores it in a variable, it just returns it outright. Whereas this stores it in a variable. So that's the main difference. So yes, you're correct. All right. Are there any other questions? Nope. All right. Let's see, 6:43. Let's move on to the next question. Prime numbers. Ooh, this is a fun one. All right. Prime numbers. I should probably erase my former solution. So a prime number is a positive integer. That means it does not have a decimal place in it, and it can only be divided by itself and 1. So a common example of a prime number is 3, 5, 7. These are not divisible by any number less than itself. So if I take 3, that can be divided by 1. 3 divided by 1 is 3. If I try to divide it by 2, that gives me a fractional value. That is not a perfect division. And 3 divided by 3 is going to give you 1. So any number divided by itself is always going to be 1, and any number divided by itself is just going to be that number again. So we have to remove those two in our definition of prime numbers, or else every number would be non-prime. So all numbers that cannot be divided by any number less than itself. So it cannot be divided without a remainder. This should say remainder, not reminder. By any number besides itself and 1. You need to write a function to check if a given number greater than 1 is prime or not. So when I say greater than 1, that means you don't have to put any extra test to make sure that it's not less than or equal to 1. So here I give it 3. 3 tells me that it is prime. 5, yes, it is prime. 10, it isn't prime because you can divide it by 2 and you can divide it by 5. So how it does that is it checks all numbers starting from 2, because I don't have to look at 1, is 2, it does 10 divisible by 2. Yes, it's 10 divisible by 3, 4, 5, 6, 7, 8, 9, up to, and not including 10. And you can check whether or not a division happens as a whole number using the modulus operator, which returns the remainder after a division. And remember that if that remainder is 0, so 10 mod 5 equals 0, or 10 mod 2 equals 0, then you know that it was a whole division, and therefore it cannot be prime. Are there any questions as to what this problem is asking us? Nope. Then I actually have to give us 10 minutes to work on this one so we have time to go over the solution. All right, I'm going to throw this in the chat. All right. All right, so we have about 4 or so minutes to get this done. We might have to go into review session on the next lecture. One thing I'm going to do here is we have 2 solutions, one using built-in methods, one using for loops. We're going to start with the built-in methods, and if we don't have enough time, we'll move into the review for the next section. All right, so the first thing I can do is I can look at all the values that are less than but not equal to this value, starting from 2. So I can build an array. So let's look at the number 10, for example. So looking at the number 10, I can build an array from 10, but I don't have to look at the first 2 values. And I have to build the keys. I have to spread it to build the array from the generator. And then I can map each value such that they are incremented by 2. And that gives me the values 2 through 9. And I have to check if any of these values divide 10. So I can say, well, is 10 divisible by any of these numbers? And it's going to return numbers here as to 0 or so on and so forth. So if I see a single 0 in here, that means that a number was divisible. So I can say, is there some value in here, some I, such that I equals 0? There is. Therefore, this number is not prime. So I take the negation of it, and that is going to be whether or not the number is, in fact, prime. Because prime means it's not divisible by any of these numbers. So I can return this, but I replace the values 10 with the number in question I am to check. All right, and I can just make a quick check here. We're going to have to save the for loop solution for the next section. So here we have 3, 5, and 10. And the answer should be true, true, and false. And there we are. Do we have any questions in the last minute or two? I know sum is a new one that I've mentioned. This method checks to see if there's any within the array such that at least one is true. All right. So looks like we're out of time. If there aren't any other questions to wrap this up, I will continue with the for loop solution in the next session after our exercise, warm-up exercise. All right, so I'm going to stop the share. All right, I'll see you all tomorrow because this week is Monday, Tuesday, Wednesday. All right.